Hello, everybody, and welcome back to math. I hope you guys had a great vacation and your brains got a good rest and are ready to delve back into fractions. So for today, we're just going to kind of review some of the things that we were working on before we left for break. Knowing that you had a whole week off, I figured it'd be useful to have a day just to kind of revisit some things. So I'm going to go through this pretty quickly and just kind of refer back to it if you need to as you work through your problem set, because I'm going to go over all the types of problems that you're going to see today. So remember, we've been talking about finding and modeling equivalent fractions. And equivalent fractions meaning fractions that are equal to each other, right? They have the same value. They cover the same amount of a whole. They're just different numbers because they've been broken up into either larger or smaller parts, right? So on this first example that we see here, you can see that I've got 1/3 shaded. And so one of the first things I want you to do is to just think about how do we find an equivalent fraction by just partitioning this up into some smaller parts. So for example, I can simply do this by drawing a single line, and now I've partitioned this into sixths rather than thirds. So my equivalent fraction would be 2/6 because I see two parts shaded out of 6 total parts, right? So 1/3 is equivalent to 2/6. If we look at the next one down, which is the same, still 1/3 to start, what would be a different way to find an equivalent fraction? Well, if I just draw more rows, right? If I separate it into some more rows, I'll be able to find another equivalent fraction. Let's say I want to separate it into 3 rows. So I can put 1, 2. Once again, same fractional part that's shaded. Shaded part hasn't changed, right? Except for we've just partitioned everything into smaller parts. And if I count 3, 6, 9, I have now 9 equal pieces, 3 of which are shaded. So another equivalent fraction for 1/3 would be 3/9. I could also write this as 1/9 times 3, right? Remember, I have 1/9 here, I have 1/9 here, 1/9 here, and so on. And I have 3 of them, so I could write it as 1/9 times 3. I could also write it as 1/9 plus 1/9 plus 1/9. Right? All of that kind of coming back to you. All of those are equivalent. They're all equaling the same thing. 1/3, 3/9, 1/9 times 3, 1/9 plus 1/9 plus 1/9. All the same part of our fraction. Okay? What happens if we have more than one part shaded? Well, not much different, right? This time we start with 4/5. We just have more than our unit fraction shaded. We have 4 of them shaded. And if I want to partition it into some smaller parts to find an equivalent fraction, I can still do the same thing. So now I've split it in half, which means I've doubled the number of parts, right? I had 5 before. Now I have 10, and I've doubled the number of parts that are shaded. So my equivalent fraction would be 8/10. I could also write this as 1/10 times 8 if I wanted to, right? Because each one of these is worth 1/10 now because I made it into a smaller fractional unit. Okay, and this is how I would write my equivalent fraction right here. This is an equivalent fraction. If you want to also show me you know the multiplication sentence to match, fantastic. It's not required, but it's awesome that you could show me how to do that, right? All right. So let's say I ask you, I'm just going to scroll down for a quick, we'll keep going with this for a minute. Now let's take a look at what we talked about right before we left for break, which is the idea of multiplying by a number using multiplication to find an equivalent fraction. So right here we have 1/2 shaded, right? Well, we talked last time before we left that if we do something like this, just like I kind of mentioned before, we've doubled the number of parts, right? We had 2 parts originally, and now by drawing that line, we have doubled the number of parts. We've taken 1/2, and we've multiplied the number of parts by 2. We've doubled it, which means the number of parts that are shaded have also been multiplied by 2, right? And therefore, if we multiply across, if we multiply our numerator and our denominator both by 2, if we double both of them, we'll get the equivalent fraction of 2/4, which is exactly what's modeled here. So by multiplying both parts by 2 or doubling both parts, we were able to find an equivalent fraction. We can do that with any number, right? So we could still start with 1/2, and then let's say this time we want to take our 1/2 and we want to, I don't know, let's quadruple it. Let's make 4 times as many parts and 4 times as many parts shaded. So I can quadruple it by making 4 rows, and now I have 4 times as many parts. Before I had just 2 parts, now I have 8 parts. And before just one of them was shaded, now 4 of them are shaded. So once again, if we decide to double or triple or quadruple or quintuple or septuple, however many, you could multiply each part by 10 if you really wanted to. You'll find another equivalent fraction. And this is actually a preview of what we're going to be doing tomorrow as well. Okay, so all of these are just review of things that we've done before. And I'm going to have you go back and just practice them. Make sure you remember how to do this all because it has been a little while. In addition, I've noticed a lot of you are struggling with your division problems on your window panes. So I just want to do a quick review of how to do division. You all have lots of really great processes and you have the right steps. You're putting your quotient down as the wrong part. So I just want to remind you about kind of where to look for the quotient. A lot of you enjoy those number bonds. You find that helpful. So I'm going to use that here. But I'm also going to draw my area model. So remember, we're taking 289 and we want to divide it into 4 equal parts. So we know 4 is going to go on the side here, right? And we know 289 is going to go in the middle, but we're not quite sure yet how many parts we're going to break it into. So I need to think about what's a large chunk of 289 that I could divide by 4. Well, I know 20 can be divided by 4. So therefore, I know 200 could be divided by 4. I know 20 divided by 4 is 5. So therefore, 200 divided by 4 must be 50. So I'm going to make a chunk of 200 because I know I can divide that by 4 nicely. And that's going to take up most of my area model. So I'm going to model it like this. There's my 200. And I've already discovered that's going to make it 50. Some of you like to write it out as equations. That's fine. So we're going to write 200 divided by 4 equals 50. Okay, just so I'm modeling all the different ways you like to show it. I've got 89 left. Well, I know 80 is also nice and divisible by 4 because I know 8 divided by 4 is 2. So AD divided by 4 is going to be 20. So I'm going to make another chunk here that's 80, and I know that's going to make it 20. Okay? Then I have 9 left. Well, I can't divide 9 equally by 4, but I can divide 8. So I'm going to do 8 divided by 4, which gives me 2. And then I know that I've got 1 left over, and I'm going to write that that's my remainder because a lot of you are forgetting to write your remainders. Now, to find your quotient, this is where people are getting a little tricked up. What you guys are doing sometimes is you're adding these parts here, and you're saying that the answer is 288. But does that make sense that 289 divided by 4 makes 288? That doesn't make sense, right? I think what you're thinking about is how much did you use before you ran out and had some leftovers. Remember that your quotient is going to be found either here in your answers or up here in the top, across the top of your area model, okay? But you're not adding these. That is not what we're adding. So if you're using a number bond, you should also write your equations and or an area model so that you can find your quotient. Our quotient would be 50 plus 20 plus 2, which is going to be 72. But then we can't forget this remainder over here. So you're also going to write remainder 1. Now, one last thing I want to model for you is a lot of you are using your multiplication to think about this, and that's so great. But you're also getting stuck on where to find your quotient. So I'm going to reverse this for a minute. If you said in your head, hey, I know 4 times 50 gives me my 200, and I know that 4 times 20 gives me my 80 to get me to 280, and then I know 4 times 2 equals 8. You're not adding up the products, okay? You're tending to look at the right for your products. If you're using multiplication to solve your division problem, you want to look here, okay? What did you multiply 4 by to get to the total number, okay? That's what you're looking for there. So just kind of be aware of that as you're doing those problems. Also, because I've noticed a lot of you aren't watching my videos, I'm going to give you a little hint right here. If you write the word pickle, P-I-C-K-L-E, on one of the division problems in your problem set today, you do not have to do that one. You only need to do one division problem if you write the word pickle on one of the division problems that you do not want to do. So go ahead, practice your fractions, your equivalent fractions. Go ahead and give a division problem a try. Write that word pickle so you don't have to do both of them, and then hand it on in. Good luck. Have fun.